Hey guys, thanks for tuning into CMTEQ channel in the series of tutorial on Raspberry Pi and Arduino programming. So basically what we're doing here is we want to use our Raspberry Pi, which we've got the Arduino that is connected to it, and we want to use it to control the stepper motor here. So basically what we want to do is from the Raspberry Pi, we want to send a command to tell the stepper motor, okay, we want you to move to an angle of 60 degree, or we want you to move 30 degree, right? Or we want you to move 360 degree, which is a full cycle. Okay, now we know that a stepper motor move one step at a time. Okay, so now this is important to know which stepper we are dealing with here. So this one is 28, right? It's a 28BYJ-48, okay, 5 volt. So that's my stepper motor I'm working on today. Right, let me just sort this out. Okay, so basically what is happening here is you have your stepper motor driver, which is based on a ULN2003 IC. That's have a built-in H bridge to control the stepper motor. Then you have to write your Arduino code. You can write code without using a library that basically you have to write a lot of line of code to control all the steps, or you make use of the popular libraries available to control your stepper motor. Now, after writing your code with the Arduino to control your stepper motor one step at a time, then your Raspberry Pi comes in to send in command via the serial port, or serially, as we've seen on the previous tutorial. Now you can set it up to send commands in terms of steps or in terms of angle, and your Arduino code need to be able to interpret the language or the values that the Raspberry Pi is sending, and then write it into the stepper driver so that it can drive your stepper motor. But now before we got into that, let's first have a look at the data sheet for this stepper motor here, which is right, the 28BYJ-48, which is a 5 volt. So this is a unipolar stepper motor which has 4 coils, and each one of the coil got one side of the pin is pulled high to the red wire, or the 5 volt. And the other side, we've got the one blue, yellow, orange, and pink, as you can see. So by controlling the signal that you send into each one of these coils, you can move one step at a time. So according to the data sheet here, stride angle, which basically mean the stepper motor in half angle usage can move about 5.6, right? 5.6 watt, 5.6 degree, okay, per step, 5.6 degree per step. So which mean, so this basically mean in order for you to complete 360 degree full circle, you need 64 steps, okay? So that is to run it in half angle. But it's important to note that the 5.6 degrees movement per step, right, which we will need 64 steps in a half angle, right, to complete a full revolution, that is only affecting inside the stepper motor, because we've got a speed variation ratio here, which is 1/64. So that basically means you're going to need to multiply this 64 times the 64 here, okay, so that you can have a full revolution on the shaft of the stepper motor. So this is what it actually means. In essence, we've got inside the stepper motor, this is what we have inside these gears here. So all the gears are connected, okay? Now, every time you are sending signal to one of the coils, you are causing one of these gears, as per the sequences, to turn, okay? Each and every turn is going to cause a step, okay? Then you need 64 steps moving on half angle, 5.6 degree, to complete a full turn, right, for all these gears. But that will only affect 1/64 on the external gear, right? That is now where this shaft is connected here. Okay, so what this basically mean, if you want to drive your stepper motor in half angle 5.6 degree, you need 64 step inside, but then you need to multiply it with a 64 step for the speed variation. So that's gonna be 64 times 64, and this is let's see, 64 times 64, that's 4096. So you're going to need 4096 steps in order to complete a full revolution on the shaft here. Okay, so that's a full story. But now, if you are using a library like I'm going to use here, which this particular library is making use of a full step mode control. So which basically mean if you are on a full step mode, you just have to multiply this 5.6 times 2. So 5.6 times 2, so that basically means 5.625 times 2, and that gives you 11,25. So we've got 11,25 degree. Okay, now this then basically means it's no longer going to be 64 to complete a full revolution, because now 11.25 multiplied by 32 is going to give you 360 degrees. So you're gonna have 360 degree in full step mode. Okay, so that means you only now have this 32, right, to multiply with these 64 here. So that's going to give you 32 times 64, which is equal to 2048. Okay, so it's basically half of this value. So in essence here, on your library, you need to feed the stepper motor 2048 steps in order for it to complete a full revolution on the shaft, not internally, on the shaft. Then you're going to see that revolution manifest here on the revolution counter there. Now, without wasting any further time, let's go ahead and see how we going to implement that. Control the stepper motor with the Arduino, but send command from the Raspberry Pi to tell the stepper motor which angle we want it to move at. Okay, right, now that we are here, if you find this tutorial useful, please don't forget to subscribe to CMTEQ channel and give this tutorial a thumbs up. That will be highly appreciated. I thank you so very much. So now I've got an empty Arduino sketch here that I'm going to first initially just write a code that will be able to just control the revolution of our stepper motor, and from there we can then be able to modify this Python script that we've been using already, just to send a command, and our Arduino need to catch it and then execute a command as per the Raspberry Pi request. Right, so before I begin here, I'm going to flash this empty sketch into my Arduino. Now that the Arduino is quiet, now we need to start writing code that will control him. So the first thing is you make use of the library. So the library I'm making use of is the StepperMotor library here. Okay, so now I'm not going to pull out that example. What I'm going to do is I'm just going to include the header file for my stepper. Okay, so that is stepper.h. Okay, now after including the header file, I need my the steps per revolution variable that's going to hold all my steps. So I'm going to say steps per revolution. You can call it whatever name you want to call it. Then, as we said, we're going to assign 2048 steps. Right, so now the next step here to define the pins in which you want your Arduino board to communicate with the driver here. Okay, so I've got a shield or an add-on here which make it easy for me. I've already selected the pins that are connected to my driver here, and I'm feeding a 5V and a ground. So this should be very easy to hook up if you do not have a shield. Okay, so the pin that I have selected here is stepper. Okay, so I'm gonna say my stepper, right? My stepper. Now this is the driver software. Okay, so that's a function you are calling from the driver, so you cannot use a different name here. You just have to use my stepper because that is defined into the library. If you use a different name, then you better write your own library so that things they don't stop working. So now I must pass the variable for the steps. Okay, so I'll just copy in there and I pass the variable for the step, comma. Now I can pass my pins that I'm going to be driving them from. Okay, so this is the pin that I will drive the stepper motor from. Now the next step here is basically moving to the setup function. Okay, now let's just run it naturally from the driver. Okay, so I'm gonna say my stepper dot set speed. Okay, now we can give it a speed of 10. Okay, now from here we can jump straight into the main loop and we can call the my stepper function again, my stepper. Then we need to access the object, and the object name is steps, and in the step object we need to pass the revolutions or the number of steps that we need. Okay, so we're going to pass it in there, and we can put in a delay here. Okay, so that we can delay after completing the full revolution. We delay for 1 second. Okay, now if everything have been captured correctly here as per the library, this is supposed to work. Okay, we are missing something there. Now we can go ahead and write the code into the Arduino. There we go. Okay, it's still a little bit sluggish here, but it should calibrate itself so that it can start running a little bit more smooth. Now notice it is stopping after a full revolution. Okay, so this is where we stopped last time, so we should reach the same spot. There we go, we're reaching the same spot and we are stopping at exactly the same spot, so which means we are successfully completing the full revolution. Okay, so this basically means our skeleton code here seems to be responding well, but now we need to ensure that we can interface, right, the Arduino with the Raspberry Pi. So if we send command from the Raspberry Pi, the Arduino should be able to catch it and execute a task for us. Now that our stepper motor is running in full cycle, in order for us to receive command from the Raspberry Pi, we need to be able to handle those commands. So I'm going to go ahead and activate the serial console with serial.begin, and we pass the baud rate. Right, from here we jump straight into our main loop, and we're going to create a function. We're gonna call this function receive data as per our previous tutorials. Okay, now this function must be defined and it is of type integer. Why integer? Because the data being sent from the Raspberry Pi will be integer variable of type degrees, locations where the stepper motor must move. Now the data are coming in serially, so we need to be able to read it. So we're gonna call the if statement and say if serial that available, right, is greater than 0. Okay, then we need to process it. To process it, we're going to create a string variable msgpi as per our previous tutorial, and we're going to store the data that we read into this string variable. So we're going to read a serial dot read string until what? Until you reach the end of line, okay? End of line character, so that you must read. So which means when you are sending here, make sure you send that character, otherwise you will be reading forever. Okay, now we then need to take this information and we need to pass it into a variable that we're going to pass into this function. Okay, so in order to do that, I'm going to create a new variable here of type integer. I'm going to say int steps, okay, and initialize that to be equal to 0. Then we come back here, we say steps is equal to msg message from pi that toInt, because now we are converting this to integer. Okay, now remember this will be angled from the Raspberry Pi, but you now want to pass steps. So what you do, you need to convert the angle to steps. Now we know that as per the half step mode, we know the stepper motor here will move 5.625 angle per step. So which means you need to multiply the number of degree angled here times 5.625, and that's going to give you the number of steps needed in order to move your stepper motor to this particular degree variable. Okay, now you can return this value, so you return steps like that. Okay, now you can take this steps revolution per revolution variable here. You're going to assign it here. Okay, you don't have to create another variable, you just assign it. So that basically means the first time you're going to run in full mode here, full steps or one revolution with 2048, and then the next time after stopping, it's going to wait for whatever value being sent from the Raspberry Pi here. Now let's write it in and test it, see if it's going to indeed work. Okay, now we open the serial monitor. Okay, let's observe. Now we're going full step, it stops. Now it's not going to go full steps anymore, because now it's looking for these informations and it's getting whatever junk value we're reading from the serial port now times this, and that's what it's running at. So now let's say we want it to run to 90 degree. Okay, so we send a 90 degrees, so it should go to 90 degree. That look more like 90 degree, but let's create a print statement here so we can see what we are also sending. So I'm gonna say serial dot print line. Okay, and what are we printing here? We basically printing msg pi, message from pi. Now let's run this in again into our Arduino. Okay, so now it's going to move full step as always, one revolution. There, it stopped there. So now from here it's going to stop somewhere depending on the junk value we're getting from the serial. Now I'm going to tell it to go 90 degree. So we're sending 90 degree. Okay, that's about 90 degree angle. That's about 90 degree. That's about 90 degrees. So if we say 180, then it should move to 180. If you send 360, then it should move to a full circle 360. There we go. Now it's moving to full circle 360 degree. Okay, now it seems like it's working there, but now let's automate this so that data can be sent from the Raspberry Pi. Now we can go ahead and write some command data from our Python script here so that we can send it to the Arduino. Now the first thing is to call the variable data. That's what we've been using on our previous tutorial, variable data, and we're going to ask for user input. Okay, Then from the user input, all you have to do is to just write a statement here, set angle, okay, so that basically what the user is going to enter. Then you get that variable, you assign it to data. Okay, now what you going to do after assigning that variable to data is basically to say, well, data is then equal to itself, obviously, plus you now need to assign the new end of character. Okay, because remember we say that if you don't do that, you're going to have a problem on this statement here. Okay, then also make sure that you cast this to a string, okay, because you have a string here and that also need to be a string. Okay, now from here you can go ahead and write it with s data. Okay, so s data that write. Now what are you writing? You are writing the variable data or whatever this statement is. That what you are writing, and you need to encode it. Okay, UTF-8. Okay, and you need to close your s data write statement. Okay, now here you basically are able to send information, but you can just print it again to see that you are indeed sending the correct information. So you can say angle, okay, and you need to pass the string and data like that. Okay, so this should be able to get you going. Let's go ahead and run this, because we know that the Arduino is already able to read information from the Pi. Now we say Arduino set angle. So I'm going to set an angle. Now which angle is this thing now running at the moment? Now it is now running on a junk angle, because remember, every time we open a serial command, or it's now going to be receiving some gibberish, but we should be able to do some modifications so that it must only read information after we've actually sent it, not just buffers information. So now let me enter a value of 90. Okay, so I'm sending an angle of 90 degree. Now things have stopped here. Okay, let's open the serial monitor. Okay, now look what's going on here. Let's send again 90. There we go. So there is a glitch in this code, but we can probably fix it. Now we can see that this is moving to an angle of 90 degree. Here we go. Yeah, 90 degree, 90 degree, 90 degree, and back to 0 again, 90 degree. Now if we wanted to move to 180 degree, then we send 180 degree. So from wherever it was written, so now it must move to 180 degree, which is half a full circle. Okay. Now let's say we want to move like 10 degree, or let's make it 11. There we go. Now this look more like 2 steps, because we are moving on half steps. This is which is 5,625. So by sending 11 degree, we basically just getting about 2 steps. So if we say 5.625 here, which obviously we're going to lose out, because remember here we are only handling integers. Okay, so let's round this to basically 6 and see what's going to happen. There we go. Now it looks like we are moving on 1 step. 1 step. Now, if you are able to attempt this by counting these single steps here, you will realize that this stepper motor will actually achieve a full revolution with 64 steps, as we've seen on the calculation with 5,65. Now, if I send a value of 12, now it should move slightly faster. Now, this will mean it will achieve about 32 steps here. Okay, because now this is in a full step mode. It will need about 32 steps to achieve a full revolution. And if I say no, I want you to go faster than that, to about 60 degree. Okay, so now it's going to move to 60 degree and stop, 60 degree and stop, 60 degree and stop. Now, you can improve this code here basically by remembering, setting up variable parameter memories that you can hold the stepper motor previous position, so that when you are sending a 60 degree, now it need to move from the previous position that it was, so that it can go to the next position. Okay, or you can also tell it, no, I want you to move 60 degree backward, because now we are only going to one direction, which is clockwise. Now, let's say you wanted to go counterclockwise 60 degrees, so move backward. So you can obviously modify your Arduino code here, and based on that, you can also set a variable and parameters to say, okay, this must be for back. So you can say, okay, I'm sending this 60 degree angle for anti-clockwise. So you can attach another message for anti-clockwise. Then you'll be able to read both variable, the angle and which mode it should go, clockwise or anti-clockwise, and you execute with the Arduino. So that's basically what you can do moving forward if you want to create something more interesting. Thank you guys for watching. If you've liked this tutorial, please give it a thumbs up and subscribe to CMTEQ channel. Until next time, cheers.